into these notes, we're going to be looking at some introductory material for Chapter 14. Chapter 14 deals with inference for regression. In Chapter 3, we learned about regression. Now we're going to do some inference, some formal inference on regression. All right. First new statistic that you need to know about: standard error about the line. Standard error about the line. Standard error about the line. And this is just really a fancy way to say the standard deviation. In one of our early chapters on inference, we talked about SEM, standard error measure, and that was when we substitute the sample standard deviation for the population standard deviation. So this is a standard deviation. We'll use the letter S for the sample standard deviation. All right, standard error about the line. This S is going to be equal to the square root of 1 divided by n minus 2, that is 2 less than the sample size, times the sum of y. Okay. We have open parentheses y minus y hat, close parentheses quantity squared. Hopefully you remember from chapter 3 that this quantity y minus y hat is the residual. And you should also hopefully see that this is an analog to our initial standard deviation calculation. Our initial standard deviation calculation said we're going to take each x and subtract it from the mean and square it and divide by n minus 1. Well, here it's n minus 2 degrees of freedom because we're talking about paired data. It's xy data, so our degrees of freedom are 2. And instead of subtracting from the mean x bar, we're subtracting from y hat, that is our predicted y. And in a manner of speaking, our y hat, our regression line, is an average, isn't it? It's one line that sort of averages out our points. So this statement here is directly analogous to our initial understanding of standard deviation. This is the standard error about the line. Next, standard error of the slope. Standard error of the slope. Okay. The notation for that is capital S, capital E, subscript B. We say SE sub B. That is standard error, and B is the statistic for slope in our regression equation. Remember, our regression equation was y hat is A plus BX, where B is the slope and A is the y-intercept. Y hat is our predicted y value. So the standard error of the slope, this is going to be equal to S, that is the previous standard deviation that we just found, divided by the square root of x minus x bar, each x minus the mean x, quantity squared. Alright, so now you can see that this truly is a slope calculation. What is slope? Slope is change in y divided by change in x. Well, this s here is strictly a function of the y values. So essentially here we're talking about y divide x. So you can see how this standard error of the slope is, again, it's analogous to a slope calculation. Right. These two formulas, you won't have to, you need to to get a feel for what they look like, but you're not going to have to calculate these values by hand. The calculator will assist you with that. Okay, next, a confidence interval. Well, we're doing inference, and we've learned two types of inference that we deal with: confidence interval and significance test. Alright, so from our formula chart, hopefully you've referenced more times than you can count, the confidence interval generic formula is the statistic, the stat, plus or minus some critical value times a standard deviation of that statistic. Okay? It's the statistic plus or minus the critical value times the standard deviation of the stat. Well, we're going to be inferring about the slope. The model has slope and y-intercept, but we're going to be concerned with the slope. So our statistic for slope, again, is B. Okay? Confidence interval. The confidence interval we're going to be dealing with is a slope confidence interval. Alright? So the statistic for our slope is B. Plus or minus critical value. Well, it's going to be a T star. Okay, and it's going to be a T star with 2 degrees of freedom, again, because we're dealing with paired data. And the standard deviation of the statistic, well, that's our standard error of the slope. So it's going to be a T star times SEB. And we're going to get this slope and this standard error of the slope directly from our calculator, from some regression output. All right. Lastly, we're going to have a significance test. Okay, again, it's going to be a significance test for slope. Well, our hypotheses will look like this. Our null hypothesis, now we're using not the statistic but the parameter. Again, back to the Greek alphabet. We use the letter beta. Looks like a capital B with just a little longer tail right here. Our assumption is there's going to be a slope of 0. That is, there's no trend. You could imagine if the points were all scattered about and there was no correlation, the regression line would have 0 slope. Okay, and our alternative hypothesis is it's going to be beta not equal to 0. It could be any inequality here. It could be less than, could be greater than, or it could be not equal to. And we're familiar with this, and whatever, this is going to be a 0 over here. So we're hoping to show that the slope is negative, it's positive, or it's different than 0. So this is pretty straightforward with what we've done previously. All right, that concludes our introductory notes for Chapter 14.